Today I want to talk about data migrations and want to provide you some strategies, tips, and tricks. Hi, I'm Philip Kalazek. I'm a Laravel developer at By5. In the beginning, I want to make sure that we are on the same side. I'm not talking about schema migrations. Those are the ones that you find in the Laravel application on the database migration folder. No, I'm talking about the client projects where a client comes to us and does not only want a new application, but also wants us to move a decade's worth of old data from different legacy systems and wants us to migrate this to the new application with the new data structure. And this is a different challenge. I need to explain this, or the reason why I say this in the beginning is that we find a lot more content about the first thing and not the second. If we search for Laravel data migration projects, we find a lot more about schema migrations, how we can add tables, change table structures, but we don't find many practical tips for handling such projects. And this makes it really difficult for junior developers who maybe have their first project where they need to handle migrations. And if you drop the term Laravel in the search, you still find a lot more content, but it's tend to be either academic in nature or very abstract in principles, or aiming at large enterprises who have maybe a dedicated migration team. So this really skips the hands over the reality of us developers experience data migration projects. And I think we can do a little better in there. So the current situation seems to be that we don't have any practical guidance. We don't see any insights in how to manage such projects. But I still think, in my opinion, this is still a common challenge. At least in our company, we have at least 3 other colleagues, and including me, who handled numerous data migrations over the years. And this is where we wanted to know what your world looks like. And that's the reason why we started the survey in the beginning, and we want to share the results about this, right?
Yes. So we did the survey. There are not this many answers, but for the data migration was the question, how often do you handle data migrations? If you haven't taken the survey, you can still write it in the chat if you want, how often you're doing it. And we have the most answers for regularly. So there are some experiences.
So unsurprisingly, we have a lot of developers, or many of you have firsthand experience on handling such migration projects. But it begs the question, why do we find not so much content for this? So is it that we mastered migrations already? And the numbers tell us a different story. I found this paper from Oracle where they're talking about data migrations inside 2 research teams, the Bloor Group and the Gardner, that find independently that 80% of data migration projects run over time or over budget. That is a such a high number. It's border on the absurd. It's either failing or exceeding their budgets for 83% of data migration projects. This is still a research from 2014, but couldn't find anything that is in between that time. In 2011, this percentage was around 40 or 50%, so it increased over 3 years to 80%, which begs the question, why do we not measure this problem anymore? And or have we already just used to it, getting used to it that such projects just fail? Nonetheless, I think we can think that, or we can believe that this situation didn't change very much. And it begs the question if you either part of the problem because you fall in the 80%, or you succeed with 20%, but you still miss the opportunity to share how you get to that success and teach others. And that's why I want to keep, well, that's the reason why I want to talk about this topic. And we want to start with the problems, the big 5 problems that I think that personally, it's my personal opinion that those problems give the highest failure rate for such projects. And then I want to continue and focus on the technical part. What practical tips can I give you that we can use in Laravel applications for migrations? Then I want to talk about 2 concepts that I think that you can use in your next project and adapt to your needs. And then at the end, I want to talk a little bit about future, what maybe is a good way to analyze such projects a little bit better. So let's get to the 5 problems I think that are the biggest 5. First, we always have different business models, which means that with each different client, we have a different challenge of migrating such data. For example, millions of properties for a real estate agency is a different challenge in comparison to, for example, cards that you have to move for a web shop. Also, we have different environments, technical environments that we are facing. So either we have different access types, so direct database connections or API access, or maybe different file formats, JSON, CSVs, whatever. They can be a challenge for himself. And the biggest problem I think that occurs is data inconsistencies. And the problem with them is that we have a hard time to find them and to handle them. And if we miss just one of these inconsistencies, can risk the failure of the whole project. Another problem is that the data that was created under different circumstances. Then now the client wants to build a different application with new requirements, with new ideas, with new functionalities that affects the data structure. And now this old data needs to apply to the new requirements, which faces a different challenge for us developers. And at the end, it's often the case that clients don't give us the budget for the project so we can spend it on migrations. No, the time should be invested in the code, the functionality of the new application. So it's get overseen that we need to manage migrations most often. And I know many of those problems are addressed in the planning phase, in the auditing and validation of such migrations, or in project management. But since we don't find any practical insights and technical insights on how to manage that, I want to focus more on that, because each of those other topics, planning, auditing, etc., can fill up a talk on their own. And still, this is a Laravel meetup, and I want to talk a little bit more about Laravel instead of planning for migration projects. So let's start over with some practical tips. And first of all, please stick with me here. I know many of those tips are sometimes really boring. They are like a gear in a pocket watch. It's just a piece of metal, but if you put every gear together, you get a valuable thing like a pocket watch. And the same applies to those tips and tricks. Each of these tips and tricks can be really boring maybe or uninteresting, but try to imagine the bigger picture of your next project where you can apply those tips and tricks and make it a success. So the first goal we want to achieve is different access types. And for that, I would always end up striving for an SQL format, because this is most often the case in such projects. We get a direct database connection or some file-based imports, for example, JSON, CSVs, or database backup files. And it's just as easy just to import them via a database management tool. For example, Table Plus does this really great, or I know IntelliJ has the data grid, for example, who manages this as easy. And this is just a matter of seconds till it's imported. So I would always strive for the SQL format, but why? Because it's the best format to find those inconsistencies, who gives us such a high failure rate. Also, it gives us a better overall picture of what we are needing to manage, the data quality, the data quantity, the scope of the task. And it gives us better preparation tools. For example, views and filters and MySQL functions, for example. And overall, in comparison to all other formats, it gives us a better performance in the import script at all. Next, and this can be as easy as just writing a second database driver in our Laravel database application, where we add just a second driver, in this example, an SQLite database. Next up, we want it to be fast and flexible. We want a fast and flexible import logic. And flexibility I would get through actions with the action pattern, because they are built with a single purpose and they are very good with their reusability. You can reuse them in many different ways. And I think they have less dependencies because you don't tend to stuck a lot of logic in one action. No, they're really built for a single purpose. So they're really easy to use in commands and jobs. But why would I want flexibility in this case? Well, for example, in my last job, in my last project, not last job, last project, a client asked me if we can migrate all active jobs, projects till they start with using the application, but later on also want to migrate single projects on demand. And in both cases, I can still use the same import logic, but in the first one, I would use them in a job, and in the second, I could use them in a command or integrate it in the UI, and this helps really well. Second, we want also fastness in our import jobs. And for that, I would use jobs and adding parallel workers that handling such jobs. And for this, I would use a main job that gathers the data, chunks it, and dispatches the subjobs that handles those chunks. Here I would use the chunk by ID method. I have seen that many developers use the offset and limit approach, where they try to get the data over offset and limit. And I will prefer using chunk by ID method, because there are really high performance issues with offset. This is because the SQL server will try to scan the table till it finds the correct offset. And this can take a couple of seconds if you are in the offset of 1,000 rows, for example. So in comparison, if you look in the integration of the chunk by ID method, it uses the last ID of the last chunk for finding the next chunk, which gives it a much better performance in overall. Because the ID of the ID column can be indexed, and so it gives you a better performance overall. Yeah. Next up, we have also the possibility, if you don't have much of many data sets, you can also use the lazy method, the lazy by ID method. This is very good for rows that are under 1,000 rows, for example. A data set is under 1,000 rows, where you can directly call the table. For example, in this code example, we have only active projects, and in this case, we are under 1,000 data sets. And for this, I would call lazy by ID and directly would handle that in the import action. So in overall, I would use for small data sets the lazy method. It has a single connection to the database, because this is something you need to remember. Working with parallel workers always needs to be thought of the connections that you can have, multiple connections that you are having from the SQL server. So for example, in SQLite, there is a little bit more problematic to get multiple connections in parallel running, and in SQL it looks a little bit different, but keep that in mind. Keep that in mind, that how many jobs are running in parallel also affects the amount of available connections that you have. So I would never use the offset and limit approach, because this would run in my subjobs. I would get the chunks with the integer of the offset and limit in the subjob. which would require me to have multiple connections available in these subjobs. And the lazy and chunk method would work a little bit different. I would use that in the main job for getting all the data and then run that in the subjob. The third thing that we want to achieve is robustness in our import jobs, in our import logic. And I would get this through transactions and exception handling. For example, we have the revert on fail strategy, where we put the transaction, the start of the transaction, outside the loop, outside of the loop of the lazy by ID loop. And we have clean retries with that, because on the first failure, we can roll back and have a clean sheet. But it's really hard for development, because you don't find all the problems at once. You're gonna get stuck with the first problem, try to fix it, retry it, get the next problem, fix it, and retry it again till you find all your problems. Another approach would be the skip on fail strategy, where you put the transaction inside the loop. So it is a transaction per imported project. So this can be really great in development, because you're finding all the problems at once, but you need good reporting for this. But because if you look in the Laravel log and find all these duplicated error exceptions, it gets out of hand real quickly. And it doesn't give you the clean retries, because some will succeed, some will fail, and then you need to decide what you need to do, what you want to do next. A different approach that takes the best of both worlds is the revert if anything failed strategy, where you have the transaction outside the loop, but track if anything failed inside the loop. And then you can decide in the end if you want to roll back again or you want to commit everything, which makes it good for finding all the problems in your import logic, but gives you also the clean retries. But again, it needs a good reporting. And I would love to go a little bit deeper in other practical tips. For example, how you get a good reporting or a good logging system going. But I think it's time for getting the first concept at hand, and this goes a little bit broader. So the first concept is not my idea. In preparation of this talk, I asked Aaron Francis, the Laravel expert of databases in our community, if he has anything to share, if any lessons learned. And he answered me with a link to an old post, to a tweet, where he explained a very detailed, specific situation where he needed to import a large quantity of data. And this was a really interesting post he sent me. But I think going deeper into this post will not help you. I would like to give you an abstract, basic version of this, and so you can use that in your next project. And if you see this, Aaron, thank you very much. So the starting point is the same. We have a main job or command, whatever you want, and gather the data that you want to normalize. He takes the term normalization, which means that it's just unnormalized if you didn't have it migrated yet. It's the old data, the basic data without normalization. So it's just the data that needs to be migrated. So the terminology he's using is the unnormalized data and the normalized data. So in Aaron's example, it was all in the same place. It was in the same place where he had the unnormalized data, the data that needs to be migrated, and the data sets where, or the models where he has the normalized data. And this gives him some benefits. For example, adding a scope to it, and with a foreign key, find out which different rows were not already normalized or needs normalization. This is a really great way to make this stepwise, to make the migration stepwise. And in our case, it could be something like a direct database connection where we use the second database driver for directly calling our table and finding it this way. This is just an alternative way that doesn't have a foreign key because it's really difficult between different connections, but you can still use this as a way to normalize your data. It's the same principle still. In both examples, we dispatch a subjob that normalizes the projects and gives also, again, the collection of, for example, 25 projects that need to be normalized. So our sub project or sub job would look like this. For example, having the collections of 25 projects in each sub job and handle them over the normalization manager. So I will come to those two components next, where we want to discuss what the normalization manager is and what he includes. So the two key components that we have in this concept is the normalization manager and the normalizers. And they have a really basic structure, no magic in here. We have the first part where we just register the different normalizers that we need. And the second part where we pipe the unnormalized data through the normalizers and apply the new transformation logic on them. Before and after the call of the normalization pipeline, I will call it, there can be your own logic on, for example, creating the new model and storing the data. Let us see an example with this concept. We have a project table with 3 columns, very basic. We need to add some transformation to the project name. We need to make the first letter uppercase and trim it. We have also a date column where so many incorrect formats were used, and a status column that is really inconsistent. So how can we apply this concept on this? We would create a project normalization manager, register our normalizers, or 3 normalizers for the name, the started column, and the status, and call these normalizers in our handle method. Now you have the opportunity to add this, to adapt this to your own needs. For example, in this code example, I use the array approach where I started an array with the new idea, with the ID, and normalize the data and save, either create or update the new entry in our database. But you can change this however you like. In the normalizer itself, we have just the normalized method where we add our transformation logic. And this is a great approach. This gives you the benefit of creating a large amount of general normalizers that can be used in different other data sets and data structures, or very specific normalizers that are, for example, very specific to projects or clients or customers. So in overall, we have this principle. We have a main job who gathers the data, dispatches subjobs for all these chunks of 25 rows. Those subjobs call the normalization manager for each of those projects, for example, and the normalization manager for the project runs the unnormalized data through the normalizers and saves it in the target. That's the first concept that I wanted to show you. And this has many benefits. For example, it's a very clean approach. You have many components that have a single purpose, that uses very small logic, and you have a great scalability. You can extend this with enormous amount of normalizers. When you look at the example, the post that Aaron posted on Twitter, he has also in place a versioning system, a preparation logic where you can load missing relationships to old data sets. And he also added some guard method where you can skip the entries that you on a specific condition. So this is really great for really large and medium-sized projects. And I really like the reusability factor for the transformation logic, where you can reuse the normalization for different parts of your data structure. But again, keep in mind, I think this is more over an overhead for small projects. But I also wanted to discuss what we want to do with an API access. For example, at least in my opinion, like I said before, I always strive for an SQL format. But how would I do that with an API access? In this example, we have on the left side our application built for the client, the new application, and on the right side, our API, where we get the old data, the unnormalized data. And I think many of you would take the approach and write the import commands directly in the application and would try to handle that this way. But I think this has many disadvantages because this will end up with messy code, because depending on which API you have, there is an excessive amount of authentication handling. It can be really slow. It can be really slow when you want to request the data, and there's no way back. You can only import it, and if the access is gone, you have only the transformed data. You don't have an original source of reference. You can't look at the data later on and look how the migration transformed the data. You only have the end result. So I think this is a big disadvantage, especially when the client comes later on and thinks that something happened with its data and says to you, hey, what happened? I think you did something wrong here, and you have no point of reference to the original source. Also, APIs is never built for the next guy to make a better migration on it. It's always built for a specific usage. Either you have a mobile app or a specific view or a third-party tool that should connect to the API. So it never gives you a database structure. It always gives you a prepared collection of values for this specific usage. So it's pretty hard for you to make the import logic to extract the data structure again from this information. What I do instead would be using an intermediate staging tool. And what I mean by that is really, it looks way more complicated than it is. This setup is like 2 minutes in installing. I would use a Laravel 0 application. If you don't know what a Laravel 0 application is, it's a repository that you find. It's from our dear friend Nuno Maduro. It's not official, but it's a micro framework from this Laravel framework. So you have all the helpers, all the tools that you have in a Laravel framework, but it is a small starting point for a console application, what we try to achieve here. And the first thing is it comes with just the console functionality. So you need to install, for example, the database component. This is creating the project over Composer, installing the DB component, and you're done. You can already write your next step, your command for getting the projects, for example. I would use an SQLite format because later on we will see that it's pretty easy to handle. I would write the command like that it gets the data, extracted, and save it as is. No transformation yet, just as is, so that you get original source. You get the source that you can reference. And with that setup, you can run this in parallel to the real development to the application on the left side. You can put this on a server, run it in the background, extracting the data next to the parallel development process, and harvest the original source. And then the next step is that you can also version and archive such SQLite files. You can make it available for your team, share it in a team. And then, of course, in the next step, when you're done with all the extracting part, you can make it available as the second DB driver, as we already told and already mentioned in the first tip. You can make a second DB driver, put it in your real application, and then there you write your import commands, transforming it and loading it to the database. that would be the concept of this approach. This gives you the opportunity to rerun the migration even if you have no access to an API. I think this is really important. And of course, again, the possibility to reference to the original data. So there are many benefits. Like I said, parallel to development, shareable in a team. You have the full power of SQL. Again, you can query all the columns, not those that the API restrict you on, no, every column. And you have the reference to the original data, the possibility of versioning it, and again, mix it with file-based imports even. You can use your CSVs and JSON files that you get next to it and import it into the SQLite database with the same data management tool of your choice, for example. So what I really need to warn you ahead is that please track the versions of your database files. If it's an SQLite file, then track those versions, put some system in place that versions those files. This can be as easy as a Git repository, a local one. So let's go ahead and talk about the future. I prepared something, and I think I want to show you first before I talk about it. It's an MCP server that runs locally on my machine. And what I think about the future is that we use an AI or a technology like MCP server for helping us in the analysis of the data migration itself. So where are the inconsistencies? Okay, perfect. Yes, here we go. So, for example, I've connected this to my own MCP server. I already thought about a query I want to put in there. For example, give me the table structure of the customers table. Or you can also ask, let's ask something better. What table structure does the staging to have? Let's see if this figures it out on its own. Yes, very cool. So it calls the function that I prepared in my MCP server for fetching the table structure out of my database, out of my migration database. I allow this, and he can then go ahead with the output and see what available tables there are, how many rows there are, and can give me a little bit a bit of preparation for the data migration itself. So let's try another one. For example, give me the table structure of the customers table for preparation of some SQL import. And we try to run this again. He finds the second function that I built, which gives the table structure. And now we can add many things together, and we can build on this. We can now ask to make a schema migration or some import script for us, and we can share our own migration that we have, and so we can find a better way to make migrations and plan them accordingly. Yes, that's it for this talk. I hope you liked it, and I really hope that you can pick some of the tips and tricks with you for the next project. Yeah.